This is a preview of some code, or what some might call low code, for an upcoming code review meeting. I'll demonstrate various features of a simple solution I quickly threw together for an in-house customer, so no one's feelings are going to get hurt if our code review panel says, oh, there are so much better ways to do that. As I describe the solution and its features, I have a story that might interest you, and I will ask several questions to get you to think about how you would approach the same solution features. In the solution, I will be demonstrating there's nothing very profound, sophisticated, or difficult for an intermediate FileMaker developer to understand. But during the meeting, we hope to get some profound critiques, approaches, alternatives, and resources we can all take away. The solution I'm demonstrating is only a small part of a much larger higher education solution we call DocuTrack. It's something I started way back in 2013 to help staff in a document imaging department to quickly track various incoming documents and packages, both paper and electronic, before they figured out what they were going to do with them in the larger electronic content management system, and that's ECM for short. Since then, it has outlived 2 enterprise-wide ECMs. So here's my first question. How is it that a lowly and even a poorly maintained FileMaker solution can outlive an enterprise-wide solution? Before continuing, think about it. In fact, DocuTrack is integrated with at least half a dozen different external systems and dozens of processes that have come and gone. If we just take a glance at the database design report, we can see that DocuTrack, well, it's the DocuTrack that we have in production, has all the following. Like 60 tables, lots of relationships, layouts, scripts. We could probably permanently clean out 20 to 30% of that. However, the file I posted for others to download only includes the following. 5 tables, maybe 44 scripts, a lot of that's extra stuff. So anyway, here's my second question. If you want to share a small part of a larger solution, how would you go about it? A, make a copy of the whole solution and remove what you don't want to share. B, carefully copy out all the parts of what you want to share to a new file. Or C, if you have another solution. We'll discuss this in the meeting. If you look at the sample file I posted, you'll probably find several random artifacts spanning a decade of haphazard and quickly developed features. But the solution I'm sharing with you right now is I just started in production last month. Out of the 60 tables that came from the production file, there are only 3 needed in this demo. The mainstay of DocuTrack is the document table. It has the containers and various metadata fields that keep bringing me back to DocuTrack whenever somebody wants to briefly or permanently store some documents that don't have a home in our enterprise ECM. In fact, when customers finally decide how and when they want to store a document, or certain kinds of documents in the enterprise ECM, DocuTrack provides the functionality of sending both documents and metadata to their new home. In the meantime, we provide various tables and even relationships from other FileMaker solution files, allowing staff to reference the documents stored here. Now, let me describe my customer's latest document-related need that brought me back to DocuTrack. The customer has thousands of paper pages of graduation rosters they want to scan and OCR the text, so they can look up people on these rosters. Notice that there are multiple people per page. When you look at the pages, they're obviously computer printouts. So my question to them was, where are the computer data for all these printouts? They don't have it. That means someone decided it was more important to keep the paper copy of the data rather than keep the electronic original. For over 1/4 of a century, these departments have been actively trying to get rid of paper and make everything electronic. But shortly before that, in the 1990s, someone made exactly the opposite decision. Third question. In 1991, What are some of the reasons, faulty or not, that someone would decide to keep paper rather than the original digital copy? Oh well. Before I get to the actual solution that I want to demonstrate, I first want to draw attention to the sample data I'm providing. At the download site, I'm providing both text input from the optical character recognition application and the 3 image documents. So my third question is, if you want to share sample text or field data and you need to anonymize the data for personal privacy, how would you go about it? And my fourth question, if the sample data you want to share is images, how would you go about anonymizing the information in the image? For this project, the first and second tasks were to get the paper scanned into images and the images OCR'd into data. So, the fifth and sixth question, what are some examples of how you would scan paper documents for FileMaker containers? And what would you use to capture data from the images? That is, like OCR them. There's a lot of examples and solutions online. Monkeybird software would be one of them that you would be pointed to quickly. And there's several plugins and other JavaScript solutions as well. Let's see. So anyway, the enterprise software that we have was already customized for workflows and would have cost a lot to create a custom workflow just for this short-term collection of static data. So we had some Fujitsu scanner software that could capture the images, and so that's what they used. But it didn't have OCR built in. That's when we remembered FileMaker 19.5.1 introduced the getLiveText function. In the sample file, I have a few sample images in the document's view layout. On a Mac or in FileMaker Go, this button here will capture text from the image and put it into this temp field. It's not perfect. Even though getLiveText has you specify the language, and I specified US English, for some reason getLiveText would give us Chinese characters and a bunch of other weird symbols no one is likely to want to have scanned or find in a document. And there's no way to configure it or to restrict its character set. In fact, if you play with it in FileMaker Go and FileMaker Pro for the Mac, I think you'll find that each can produce different results scanning for text from the same image. For that reason, and the fact that the department uses Windows exclusively, I didn't pursue that option. If you like, you can compare and try to parse the results of getLiveText instead of the sample data from the OCR application that they ended up using. And that was Abby FineReader, because it was already installed on a laptop that they have, and they could customize the output somewhat. Ironically, the laptop is a MacBook. Some OCR software tries to create zones and find columns of text. Unfortunately, this is often inconsistent if the content isn't perfectly consistent. On this page, we can see how Abby FineReader found nothing but single column zones. That's good. Maybe, although you could see 3 columns there. On the second page, it made 2 column zones, sometimes grouping the rows appropriately and sometimes not. And this third page defined both single column zones and 7 column and maybe 6 inconsistent column zones mixed in. It was too complicated manually defining 3 columns for 8 rows per page for all the pages, so we just forced 1 large zone per page and decided to parse the data from that. I'm pretty sure there's better software for this. In fact, back in the 1990s, we already had an application at San Jose State where we could define consistent zones and restrict what kind of data and character sets could be in each zone, so that it wouldn't make nonsensical guesses of what the text was if it was having trouble reading it. My 7th question, now that you have the data captured from the images, how are you going to put it into your FileMaker solution? I thought getting the data from straight OCR output would have been simple selections by text position or by label, but It wasn't something I could immediately finish in my spare time, so I had to put it off for a couple weeks. In the meantime, the imaging team has a staff member who went to training for regular expressions. So she took several stabs at it, but really had a lot of trouble capturing the name and sometimes associating the name with the correct data. So maybe this can be my 8th question. How would you propose finding and extracting the name in this sample text? Now look at the text carefully because there's some inconsistencies there. Later, my friend on the imaging team and I were talking about ChatGPT, and I said, I wonder if the AI is smart enough to extract the data if we just ask it to. We wrote, give me the name, GPA, major, and rank in comma delimited format from the following text. It did it, and the output looked great, except we were limited by the amount of source data we could give it. So then we asked ChatGPT if it could write us a regular expression to extract name, GPA, major, and rank for us. It did it again, and the output looked great. Well, it looked great at first. The problem was the source data was inconsistent, and it was too easy to associate data to the wrong person. We saw later that the OCR was inconsistent about defining columns. Sometimes it would, and sometimes it wouldn't. Really dumb. Kind of like one of those places where you'd expect a little bit of artificial intelligence to be in play. Even when we told Abby to give up on guessing columns, the distance between columns made it frequently misalign rows, and it didn't even try to use the dashed lines as a clue between records. I've only dabbled with regular expressions, so I thought I'd give a FileMaker calculation another chance. I figured a while loop could go through the lines, or values, of data, lock on to some simple and most consistently recognized label like rank, and then look around on the current line, the previous line, or the next lines for the rest of the data they wanted to extract. After a few tests and loosening the text search criteria to account for inconsistencies in the recognized text, we were able to get the right data on the right record and in the correct fields 98% of the time, which was a lot better than what the other methods were doing. As bonus references, we keep all the unparsed data for the record in a separate field, and we are able to find and insert into a related container field the original scanned image from the same folder where all the OCR text files were located. So, that's great. AI hasn't replaced us yet. If you download the sample file, you can see the calculation I hacked for the solution. Note that I keep a FileMaker variable array on the side as a simple way to store all the unparsed lines before putting them into record storage. I'll be a little disappointed if someone else doesn't suggest a better way to code this, since I didn't stand back for even 2 minutes to approach the problem strategically. This is all brute force trial and error code. In the sample file, input text goes on this tab, the calculation goes on this calculation tab, and the output automatically shows up on the output tab. If you have a folder with all the images and text in one place, this import button will let you select that folder, import all of it together, and then export to the graduation catalog table, which is what this export button can also do as a separate step. Over here we have the graduation catalog layout where each person gets stored as separate records. The sample data I provided doesn't quite reflect it, but using 10 pages of test data, the calculation was able to get all the data from the correct locations into the correct fields, despite the recognition not being all that great. This information popover button is just some metadata. The script button opens a new window displaying both the image, if it could find it in the folder, and the entire block of text scanned for this record, just in case the actual data they need isn't in the field where it belongs. They can perform finds here and recover data from here. If you navigate records on the graduation catalog layout, it will drive the source layout window to the correct related data. Notice, if you move and resize the window and close it, it remembers the size, location, and even the display it was on if you open it again. This is useful for the customers who have multiple displays and set their windows to optimize their work. So, if you have other ideas how you would complete this project or just want to see what others have to say, come to our upcoming meeting. If there's time, we can do code review on ideas you or others have to share.